but we'll see.
Time will tell. Here we go.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
And I'm Kristina Panos, assignments editor at Hackaday.
This is episode 169, 3D print Vase mode engage, measuring nanovolts through mega DIY, and the softest pants are software pants. In the news this week, we've got news from space. This is kind of long anticipated news, but it was just released this week that the Event Horizon Telescope Project Consortium got a picture of Sagittarius A star, which is the black hole at the center of our very galaxy. And if you look at it, it's a smudgy bright donut.
A forbidden donut.
It's the donut that's, holding our galaxy together. So you got to give it credit for that. No, it's the ring of light from behind it being bent around the black hole. It's got to have a dark center. That's the light that doesn't make it through. And then the stuff that gets bent around. I think what's interesting about this for me, I used to do some astronomy as an undergrad, is kind of the scope of this project. It ended up being like more than 300 people and like 20 observatories 80 observatories working together to kind of take the information coming from a whole bunch of radio telescopes scattered all across the Earth and kind of synthesize them together into this one picture. And I watched the talk. They were saying this is like the most scrutinized photo ever. The most scrutinized astronomical image ever made. But yeah, so this was what a team of people got the Nobel Prize in 2020. That was Roger Penrose, Reinhard Genzel, and Andrea Ghez got the Nobel Prize for even kind of thinking that you could do this and take an image of the black hole at the center of the galaxy. If you've got pictures of black holes in your mind, that was M87 that was the first black hole ever directly imaged. And that was 3 years ago, fairly recently. This is the black hole. This is the one holding our whole spirally galaxy together. Sagittarius A star. So pretty cool. This was kind of the holy grail for 30 or 40 years, and it just happened last week. And in other breaking 3D printer news, Tom Nardi was on a virtual press conference where MakerBot and Ultimaker announced that they were going to merge. I guess both of them had their roots in the early RepRap kind of open source industry, and both of them went on to making, more expensive, maybe more reliable machines, maybe not with MakerBot. Ultimaker has also been supporting the open source Cura slicer program that I know a lot of people out there use. I thought it was really cool that the former author of Cura Dade and the current maintainer of Cura, Jaime van Kessel, were both in the comments saying, don't worry folks, Cura project is still funded and is still going to be worked on as open source. So don't fret about that. And I think that basically was the only concern any of us in the kind of hobbyist community have anymore. The Ultimaker machines were always super expensive, and since MakerBot got taken over by Stratasys, they haven't been the same either. Go see Brian Benchoff's marvelous RIP MakerBot article from, I'll throw the links in the show notes. Yeah, so what does this mean for the hobbyist casual 3D printer community? Probably not much. The combined business is going to focus on the kind of middle high end light industry printers costing in excess of $10,000. So if you're looking for something more on my budget, you're not going to get it from them anymore in the future. But, frankly, you weren't getting it from them, either of them, before in the past either. So, I think no big deal, but it's interesting to see these two kind of formerly hacker makerspace projects companies go up into the stratosphere or something.
This is a journey into sound.
What's that sound?
What's that sound?
And that brings us to this week's What's That Sound? This week is a prize drawing week. Last week, I played a sound for you all to guess. Do you want to have a listen, Kristina?
I already did.
Oh, do you know what it is?
Well, I doubt it, but I think it's a shortwave radio.
Definitely data something. This one is actually, drumroll please, a Commodore C64 tape drive.
Oh.
Yeah, I had no idea, actually. I went looking for audio samples, and it didn't sound at all like I remember it in my head. It sounds significantly like, I don't know what, clickier, white noisier than I expected. I thought it to be more like modem soundy, I guess. Anywho, the correct answer, nonetheless, was Commodore tape drive. And the first answer from Bobbert 2.0, patch level 1, was Commodore tape drive loading what sounds like it is clearly a pirated game. And I would love to know, Bobbert 2.0, patch level 1, how you think that you could tell if it's clearly a pirated game, or are you just playing the odds on this one? Anyway, in honor of a super tricky one and the 9 correct answers we got out of this, I have put together a kind of convoluted random number generator. It is a high speed, well, not super high speed, an audio frequency square wave generator running at about 1.5 kilohertz. So certainly faster than I can see it blink. Driving into a counter, and I'm just going to plug it in, turn it on. When I do that, the LEDs all look red to me. I'm just going to unplug it, and there's going to be a binary number left over on there, and we'll see if it's between 1 and 9. If it's not, I'll do it again. And the winning number is unplugging. Oh, dude, I have to do it the other way because it's all like glitching.
Oh.
This is what I get. All right, let's try this one more time. And the winning number is, too high, 10. Okay, wait, and the winning number is, I swear to God. And the winning number this time for real is 11. And the winning number this time is, okay, there's 10 again. What the heck, man? The winning number is 8. Congratulations. Whew, finally got one with a number that was less than 9. Number 8, binary code played at audio frequency, i.e. playback from vintage computer program on regular audio cassette player. Good enough by me. Congratulations, Jolly Taper. I'll get an email out to you. We'll get you a Hackaday podcast t-shirt. The rest of you stay tuned. Next week, I'll play another sound, and if you can guess what it is, you have your chance at getting a t-shirt. And that brings us to the hacks this week. I'll start off with Ben Eady's 3D printing hack leverages Vase mode structurally. This is a really clever trick. Ben shows it off in this video. Basically, Vase mode in a 3D print is where you print one shell continuously. And so, like if you imagine a vase, it has the head of the 3D printer just kind of tracing the rim of the vase and slowly spiraling upwards in one continuous motion. You can, of course, warp it and make it arbitrarily fancy, but the point of the matter is the head never picks up and goes somewhere else. Vase mode is limited in the kinds of things you can make, but it is a lot faster because the 3D print head never spends any time, picking up and traveling over to a different place. Ben's idea here is to make a quasi Vase mode print that's a little bit more 3D, so it's kind of like a shell, so that it's both stronger and quick to print. And that's what he gets here by making essentially like corrugations in a 3D print. So if you imagine the outer shell of like a bust, and he does a Moai statue and a bust of his own head and stuff, it's got 2 walls and they're separated by occasional vertical lines going between them, just like kind of like looking down the side of corrugated cardboard. He does this in a super clever way so that it can be one continuous print. Where these little vertical ribs go, it's actually a line that goes down and a line that goes back up. They're just separated by a distance that is smaller than the extrusion width of the plastic as it's going along. So they kind of merge together, and it looks like a surface that you would have to make by having travel moves, but it's actually not. It's two surfaces together, but they're strung together by these clever interweavings, with the exception of one place where it actually does kind of cross over. So I think topologically, it's kind of like a C, where the two parts of the C get so close together that they're almost like a ring. And in fact, here they do merge together because the melted plastic smooshes up to the melted plastic. I just love these kind of tricks. He's getting kind of a 40% reduction in print time for the kind of prints where it's suitable to do this. And, that's probably not structural things where you need it to be really strong and resist like compressive forces, but for things like a helmet or a vase or, a pillar or stuff like this where you're not going to like be squeezing it hard and it's not a functional printy part, but rather something decorative. I think this is a very clever idea, and I just love this kind of trick.
It is very clever, and before, when he's showing it in Kira, it reminds me of kerfing in a guitar, but it also reminds me of just what you would do to take a solid piece of wood and make a curve out of it. One of the ways you could do it by
Right.
cutting little things out of it if you didn't want to bend it with water. Yeah, but that's very cool.
A bunch of people in the comments said, this is something the slicer program should do and you shouldn't have to model in. But a lot of the time, our slicer programs don't know what we want from them. Like, they don't know what our design intent is. You just give it, like a 3D thing, and you're like, here, slice this up for me. And you don't say to it, this has to hold weight, or this has to be strong in this direction, or, don't worry about it. It's just, a bust I'm going to put on my shelf. Like, the slicer doesn't know any of this. And so a lot of the time we have to kind of trick it by modifying the underlying model. I can think of two more that should be in everyone's mind that are kind of along the same lines. One is making a thin web to bridge holes together where otherwise it would be kind of an unprintable overhang. And I do this all the time when I have like a bolt or a screw that needs to go into a part. So you need a thin hole for the part that's going to take the screw threads, but then you also need a bigger hole for the part that's going to get the head of the screw itself passed through it, right? So you have like a 3 millimeter hole for the threads and then a 6 to 8 millimeter hole for the screw head. And if you have them printed the wrong way, where the little one is stacked up on top of the big one, there's an overhang. And one clever trick around this that we've covered actually twice on Hackaday, links in the show notes, is a clever way of putting a super thin layer there into your model so that the printer will think there's a layer there and just kind of print a sacrificial bridge layer across that then makes the small hole come out right on top. Another old trick that I haven't seen people use much but was super fashionable in the 20-teens was to put internal holes into your 3D model to fool the slicer into making extra perimeters on the inside of it. And of course, they're not visible from the outside, but if you're worried that you need more support structure here for extra rigidity or compressive strength there, you can put a hole in the middle of it. And if you make a lot of these holes, the slicer program will, of course, put perimeters around these holes. And where the perimeters are, especially if you're using multiple perimeters, you get these kind of strong columns of basically solid plastic around that hole that you added in. So you can, ironically, fill your 3D model with holes, and it'll fool the slicer into printing more plastic and making it stronger. And that's actually almost exactly what Ben's doing here, except he's doing it to have it in vase mode. He's making these tiny slits in the thing where then it fools the slicer into making ribs.
My first hack this week is a Hackaday prize entry. Vintage phone links the past to the present and future. So what Giulio Pons did is take a very cool looking vintage rotary phone and turn it into a digital assistant that has an analog interface. But fortunately, Julio was able to reuse all the good bits, like the hang-up switch and, of course, the rotary dial. And to make this all functional, he connected up a Wemos board and a DF player for the recordings. And then to make the bells ring, because, of course, you have to make the bells ring. I mean, come on. My favorite part is that there are so many ways to go about making the bells ring. A lot of people will tell you you need 48 volts, which is how it worked back in the day. You got it from the central office. But what Julio did is he boosted up the voltage up to 12 volts and used a motor shield to drive the bells. These hacks always make me want to do so many things with old rotary phones. So I was looking up ways to do that, and it got booted out by somebody in the comments saying what they did, what they have done in the past, which I thought was awesome. Mac Simsky says, I glued a buzzing motor from a mobile phone to the arm of the ringer. No booster or motor driver necessary. Only a resistor, transistor, and a diode. Oh, that's clever.
Totally cheating.
And another commenter, so one thing I've always wanted to do with two phones is make an intercom system. And I'm pretty sure we talked about this the last time I was on the podcast. Where you pick up one phone and the other phone rings. But one commenter brought up something called a ring down device that makes that very simple.
What does it do?
I have a type of intercom set up in my home. I used a device called a ring down, which can be found on the internet for a price. Thank you. The ring down has two phone jacks on the front and a power connection on the rear. The idea is if you pick up the phone A, phone B will start ringing. If you pick up phone B, phone A will start ringing. I have mine set so there's 4 seconds of dial tone, then ringing.
Oh, cool.
Ring down device.
That sounds like what we need.
You can attach 2 standard telephones to this controller and it will initiate a call when either phone goes off hook. It's only $160. Ooh.
Oh, we might have to figure out how to do one of those yourself. My next hack comes from Jaromir Sakuba. The title is Nanovolt Meter Requires Careful Design for Accuracy's Sake. This is an insane bit of high precision, voltage meter design and his fantastic write-up of it. It's in response to a challenge put out on xdevs.com, which is kind of a site for metrology freaks, for lack of a better word. These are people who are interested in getting voltage references just right, being able to measure impossibly small voltages, impossibly accurately, tiny currents, you name it. This is like kind of the hard stuff in analog electronics. And they put out a contest to make a voltmeter that rivals the best available voltmeters out there, the really expensive stuff that costs you thousands and thousands of bucks. And Jaromir took up the challenge. He actually won the challenge as well. He's the only entry, but he completely blew away all of the requirements. And his write-up of it up on GitHub is fantastic and goes through kind of all of the heavy-duty electrical, mechanical design challenges that come along with trying to measure nanovolts. Noise floor, it has to be able to measure 10 nanovolts and have noise less than 30 nanovolts. And I think he got it under 20 nanovolts of noise. Shouldn't surprise you that the first step in having a meter that is able to measure these voltages so incredibly accurately is having an incredibly accurate low noise front end amplifier. And I think he spent most of his time on this part of the design. He names all of his boards after the Simpsons. I think the LNA was Bart. Homer was like the brain board. Lisa was the communication board on the back. Meggie was just a button board, and Marge was the power supply. But the Bart board here is really kind of clever. There's a whole bunch of ways to making a super low noise amplifier. And again, we're talking about noise that's down in the kind of 20 nanovolts range, where, like, in contrast, my oscilloscope over here is kind of good to 20 millivolts. This is like 3 orders of magnitude down from that. He can't even buy JFET amplifier chips that have this low a noise voltage. The one he ends up using is spec to like 210 nanovolts. And so what do you do if you have some noise in your system? You kind of average things together. And so he ends up on this board having 100 of these chips all averaging together, and that gets the total noise out of the system down below 20 nanovolts, which is pretty crazy. There's all sorts of other tricks, like there's a little bit of leakage current, so he has another part of the circuit that injects current back in to make up for this leakage current. The biggest concern, I guess, when you're measuring things this small and this accurately is that if the temperature changes, then wherever two metals touch each other, they'll generate a little bit more or a little bit less voltage. And that's measurable on this scale. So he's got all sorts of kind of thermal EMV problems here and has to take extra concerns about that. And he's got air shields over some of the parts to keep them from, getting wind blowing on them or convection currents inside the case, which would then make them have kind of cyclical fluctuations in the measured voltage. And he takes all of this stuff extremely seriously, to the point that one night he leaves it running and leaves a window open so that the temperature in his house goes from like almost kind of room temperature, almost 20 degrees, down to like -5 degrees. This must have been in the winter. How's it so cold? Anyway, he notices that the voltage noise isn't correlated with the temperature in his house overnight as it goes really cold. And so he's pretty happy with that. The write-up is just full of detail and a fantastic piece of engineering. Basically, he's made an accessible, open source, hobbyist, buildable, high-end piece of equipment for kind of $400 in terms of his estimate of if you had to buy all the parts new in single quantity versus, thousands if you had to buy one of these things. So this is a really sweet piece of work.
I agree.
And what happens if you win a prize on a Metrology Nerds website? The answer is you win a... What did he win as his prize? He won an ADR 1000 ultra low noise voltage reference that puts out a superbly stable 10.00000 volts DC. And so if you want to continue your projects and make this reference meter even more accurate, he could probably boost this thing in there and pull it up.
My next hack for this week is why get dressed when there are software pants. Everything is hacked seems to not like to wear pants very often, and thankfully they work from home, so it's not a problem, except when it is, and they stand up or otherwise shift into view their lack of pants into the camera for everyone to see. What they did is use machine learning to track posture, body posture, and landmarks on the body, like the shoulders and the head and so on. And then it figures out where your region is that's not safe for work and blocks it. So it basically figures out when it's come into view, oh, we need to throw up the pants. They don't just come in one size. You can make them as wide as you need to or whatever, and you can even change the pattern to match your outfit if you want to. My favorite part was that everything is hacked seemed to enjoy working on this out in public, but they got some strange looks getting up and, putting their groin on camera and checking to see if their groin was on camera and so on. So it changed to a pants mustache, which is quite funny, especially when it's super long. It's like black walrus teeth hanging down.
Skinny jeans mustache.
Yes, exactly. It's the new thing. But yeah, so I myself have come to really dislike pants lately. And the difference for me is that I always had to choose my outfit carefully for going out to the office, because that's a long time to have to wear something that is uncomfortable or becomes uncomfortable after a while or whatever. With working from home, you can just change your costume whenever you need to. And going along with the psychology of wearing work clothes to feel like you're in the work mode and so on. And it's just, yeah, I've had a lot of fun lately buying secondhand not pants to wear. And especially with a dress, you might, if you're not used to wearing skirts or dresses ever, you might think, those are uncomfortable. And while it's true that certain classes of dresses, like in skirts, entire classes are uncomfortable, like the pencil skirt or the mini skirt, depending on your preferences, there are entire classes that are comfortable, and many of them have pockets and so on. And just, yes, it's very freeing. It's like picture a loose belt and then nothing below that, and that's what it feels like. So why wouldn't you want to sit all day in that kind of comfort is beyond me.
Software pants are the hack to avoid wearing a skirt, is what you're saying.
Yes. But some people get cold, I don't, and depending on the chair you have, like I have not to brag, but I have an Aeron chair, and like the thought of my bare legs on the Aeron chair is just not, I don't want that mesh imprinted, it wouldn't stick like the vinyl car seat in the summer, but it's still not good.
My workaround is a standing desk. So like I would have to jump, a meter into the air for anyone to know that I'm in Telcos without pants on. So take that.
I want one of those underdesk bicycle things. It'll interfere with my foot pedaling a little bit, but...
Oh, right. Yeah, your foot keyboard is not going to work if you have to be pedaling, like bicycle pedaling. Yeah, I have no idea if this is cool or crazy or the most frivolous use I've ever seen of computer vision applications. But I don't think you need any excuse to make funny computer vision applications either. I mean, you can even wear pants and this would be cool. My next hack is really a video. When hams helped polar researchers come in from the cold. Al Williams wrote this up. It's a video by the history guy. In the International Geophysical Year, 1957 to 1958, there was a team that headed down to Antarctica and established some permanent bases there. I think the main one would be the one that would become McMurdo Station, although don't quote me on that. The way they could then communicate with people back at home was by using ham radio. And so the stations would call in and hope that some ham radio operator in the States would hear them and then would patch them into their destination by phone, by like switching it over. And that's what this video is about. What's funny is my father actually did a bunch of work in Antarctica. He was there in the summer. He never wintered over, but he'd be gone and would have to call us over exactly these crazy ham radio links, exactly like this. And this is in the late 80s and early 90s. This history guy video is about the kind of early days of volunteer ham radio operators patching in people in Antarctica. It actually continued up until they got reliable internet down there. And that's really funny. The calls would all be simplex. And so you'd have to talk for a while and then say over. And then the ham radio operator listening in the middle would flip a switch. And then the other party would be able to talk for a while. This all started actually when I was a little kid. And it was really just the craziest thing to be up in the middle of the night getting this random phone call from some random radio operator who's sitting there flipping the switch so that I can talk to my dad by bouncing sound across the ionosphere. In this video, they talk about one particular ham radio operator who did this so often that he, got invited to somebody's wedding and et cetera, et cetera. It really is a great service that kind of random volunteers were doing. My dad was down there maybe 6 times, 7 times. The absolutely coolest thing that happened, we were staying with some friends of the family for a while, and we were eating breakfast that next morning, and the father of the family was like, I got the weirdest prank call last night. It was this guy claiming to be Santa Claus. And we're all like, okay, what? And we were talking about this for a while, and eventually he's like, yeah, he said it was a phone call from the North Pole. And we're like, oh, you idiot. That was my dad. He must be at South Pole Station. And he was just like, again, this is at like 3 a.m, right? And so he wakes up to this crazy phone call, and the dude on the other end is like, hello, are you willing to accept a phone call from the South Pole? And he must have forgotten that my dad was in Antarctica, or he didn't put two and two together, or it was 3 in the morning. Anyway, he was like, the next morning, he was like, I got this prank call from Santa Claus.
Well, isn't that, I mean, it's akin to a disaster area, though, but isn't that what ham radio is for? To connect people in otherwise desolate. Yeah.
Yeah, exactly. I don't know. Again, it's all volunteers doing this, so it is kind of a tremendous service.
Oh, definitely. My next hack this week, transparent frame deck is clearly capable. Now, if you haven't heard of Framework, they are a modular laptop company that has all these modules that you can add on, and the laptops are all user serviceable, so it's pretty cool. And this company offered one of their laptops plus whatever modules to Richard Sutherland that he needed to build something awesome, and Richard totally delivered, building this see-through frame deck, as he calls it, with a custom keyboard. I don't know what it is about transparent things, transparent electronics in particular, and I would say that they need to bring them back, but I feel like that might dilute things. Richard took the board, which happens to have 4 USB ports on it, which is pretty handy, and he built a slab-style computer like the Trash 80 Model 100. I had a Trash 80 Model 2, which was much bigger, all-in-one, that took 8-inch floppies, IRC. It was just a one-piece thing that was very back-heavy, and you didn't want to hold it by the keyboard, even though the keyboard was pretty tough. One of the mind-bending things that Richard had to do was design a layered acrylic case around all of the things that he wanted to put in it, and it turned out really well. And the build tour is a nice place to go. I've got that linked in there. And one of the things you don't see from the top is a very utilitarian aspect of it is that Richard angled it. He put these conical repositionable feet on the back and then rubbery feet on the front that are sort of like what you'll find on the bottom of your mouse. But they're thicker than that. They're kind of I also have a link for explaining scuff feet in the article too, but they're kind of an attempt at unifying keyboard feet. So yeah, I don't know what it is about clear stuff. I love it. I have a collection. I had a clear phone when I was a kid, and I have one now again. I've got a clear TV, a clear stapler, radio. And the best part about it is when they jazz up the electronics, like the phone. The bell is painted like bright orange, and actually the circuit board is actually painted. It has this red swoosh through it. I should put a picture of it. I'll put a picture of it if we want to use it. It's just like every part of it is candy colored and bright, except for the resistors. They didn't use audio resistors or anything.
Well, I guess if you're gonna see the insides of it, you have to put all that extra design work into making the insides look good, right?
I think you'll sell more units if you do. Yeah, I just love see-through things. Show your work.
Exactly.
Long division.
My first quick hack, gaming mouse becomes digital camera, is a reverse engineering by Ankit. He got given a Logitech G402 gaming mouse by his brother and thought he would take it apart. Now, we've seen a lot of projects that reuse the interiors of an optical mouse to get the camera out. What I liked about this one is that he also reprogrammed the microcontroller on it. It's an STM32F102 to do the work for him. So basically the hack's really simple. It's solder some programming wires on and write a bunch of software making the camera appear as a USB device on your computer. Really sweet piece of work, and it's all up on GitHub. Next up, Coloring Computer Needs No Batteries. This is a logic game circuit simulation coloring book for kids. I think it's pretty fantastic, and why did we settle on logical ones and zeros and voltages when we could have done the whole thing with red and green? It's really cool. It seems far out at first, but it actually looks like lots of fun. And last up, Mini Disc Player supports full data transfer from Asivery. If you've used mini discs, they had a horrible anti-duplication proto-digital rights management feature put on them by Sony. Thanks a lot, you jerks. Which was you couldn't ever make a digital copy of it easily. Actually, you could. There was an old workaround with the Toslink cable. You could get the digital data out that way. But that means you have to play it at full speed, and you can't just dump the data from it. The one exception was Sony's ultra-high-end RH1 player, and Asiveri's hack here is awesome. He taps into a 40-second DRAM cache line in a much cheaper mini disc player and just reads the data out of there 40 seconds at a time, and then has full access to the digital file format. This hack is in its infancy, but will probably turn into something that will be of use to people who have mini discs and they want to archive their collections before the last mini disc machine ceases spinning.
All right, my first quick hack this week. Printable fix for time card clock has owner seeing red again. And that's red as in the red timestamps. So Morley Kurt got this really cool time card clock for a project that is still a secret right now. And it worked, but it was missing a crucial bit inside. The ribbon advancer gear was just gone, and I still find it strange that this piece would just be gone and not broken in half, broken in half in the bottom, or it's just gone completely. Anyway, he wrote to the manufacturer about getting a new piece. They wanted $95 for one, plus shipping. With very, very little to go on, Morley ended up designing and 3D printing a new one. All he had to go on was the shadow of the part that was missing, and he found one video on YouTube featuring the time clock. While it definitely took some doing, it wasn't an impossible thing to do. And version 1 didn't work, of course, but version 2 was perfect, and it only cost 9 cents for a total of 18 cents.
3D printing for the win.
For my next quick hack, balloon guitar is an absolute gas, helium or not. And here, Matthias Krantz has tested the utility of helium inside of a guitar to see whether it will turn into a ukulele or not, pitch-wise. The coolest part about this, I think, is the testing rig, because he doesn't just make a balloon guitar and then try that with helium. He also uses it's either a small suitcase or a vinyl couch cushion with a handle on it. It looks like it could be either one. But he tries that out, and, well, the answer is that helium doesn't change it. But that balloon guitars actually sound pretty cool. And who'd have thought that all you need is a resonant cavity in some form or another to make a playable guitar. All right, for my last quick hack, making a concrete pinhole camera. Now, as Lewin explains, a pinhole camera can be built out of virtually any closed chamber with a pinhole-sized hole in it to allow the light in. Pinhole cameras exploit the natural optical phenomenon called camera obscura. If you get the light just right through the little hole in the mini blinds, you can get lucky and get a picture projected on the wall of your room. This person made one out of concrete. I've always meant to make one of these, and I never have. I have the feeling that once I make one, I'm going to make dozens of them.
All right, well, that brings us to our can't miss articles. These are long-form original pieces by our fantastic Hackaday writing staff. And this week, I'd like to kick off with Arsenius Pichugin's NVIDIA releases drivers with openness flavor. And those of you who've been following the Linux scene for a long time have known that NVIDIA has never been really friendly to open source software. They hide a lot of their secret sauce in their drivers, and so they don't feel like they can open those up. And so Linux people have had to kind of reverse engineer things to make their graphics card hardware work with our operating system. And so after 20 or 30 years of kind of being at loggerheads, NVIDIA looks like it's taking steps slowly, like AMD did a decade ago, to open up some of the kernel modules for its video drivers, and in particular for its newest video cards. This is really kind of cool on one side in that it makes I guess, the most obvious interface between the graphics hardware and the operating system, at least, open source, and so hopefully will be better debuggable, will end up working smoother, end up being better integrated with the whole Linux ecosystem. And so that's actually pretty awesome. The part that's a little bit less awesome about this is that, of course, like I said, NVIDIA needs to protect its graphics secret sauce. And what's happened here is that it's basically moved that secret sauce out of drivers into kind of firmware hidden on some chips on the device itself. This isn't kind of giving a glimpse into what's going on in the graphics cards at all. But what it is doing is making the kind of last stage interface between the card and the operating system more open. So what am I going to say? In that sense, it's a step in the right direction. But then I think a lot of people are rubbed the wrong way because they see other companies trying to kind of move in the direction of open source stuff by just taking the stuff they want to hide and moving it deeper and deeper into hardware. And that doesn't necessarily make things less opaque or easier to use. And so there is kind of this tension here. And Arsenius and I were talking about this, and I actually ended up writing the newsletter about this last week because this is kind of something near and dear to my heart, because I use a lot of, I use an absolute ton of open source software, and I've experienced the problems when the hardware is not compatible with things and when the drivers are crappy or they require you to pull in binary blobs that then don't get updated with the rest of your system. And so you have to run these archaic 10-year-old pieces of software just to get a thing of hardware to work. And so in that sense, I'm totally stoked about this NVIDIA driver thing. Maybe that side of things will at least make a little more progress. But we're going to be open by pushing the stuff that we want to hide into firmware and just calling it firmware. Isn't firmware software? I don't know. I don't know what the difference is between firmware and software anyway. It's all code to me. Firmware, I guess, has traditionally gotten kind of a pass. I guess people don't usually want to know what's going on in the firmware of their devices. And I think the kind of traditional open source software movement has kind of turned a little bit of a blind eye to what's going on the firmware side of things. And I think some of them are kind of now, I don't know if waking up is too strong a way to say it, but I think some people are finally kind of catching on that, yeah, firmware is just software too. And, it's important for it to be inspectable. And especially if you're concerned about security, it's important for it to be inspectable. But even just for interoperability, even just for getting the stuff working, it's nice if you can see how it works on both sides and not just on the operating system side of things. So, I don't know. Mixed news, I guess. Here we are complaining about it. It's a step in the right direction for sure. So that part is probably actually good news. And whether here the best is the enemy of the good or the better, I guess we all have to think about that. And certainly that's kind of the flavor of a lot of the comments on this one.
My can't miss article for this week is Maya Pasha's Silence of the iPods, reflecting on the ever-shifting landscape of personal media consumption. So the news here is that Apple is discontinuing the iPod Touch, which is the last soldier to fall in the iPod line. And Maya gives a great history of really the entire personal music player scene, starting with the veritable Walkman of 1979, and moves through the other players, in the field, like Diamond Rio and the creative players. Personally, I had a Sansa first, a little tiny,
Oh yeah.
little Sansa, and then I had a Zune.
Oh no.
But now I'm probably wrong on this, But I feel like the Zune did more things than just play music before Apple had,
Yeah.
before any of the iPod. Okay. And that doesn't suit everyone. I have to wonder, do people just not want single-purpose devices at all anymore? Does everything have to be a Swiss Army knife? Or at least a TV VCR combo situation? Yeah, I don't know. I also I had a mini disc player, which I still do. I still use it. And yeah, putting music on it is kind of a pain. Partially because I don't do it that often. Partially because I have to remember that you have to use Sonic Stage. And I have to remember how to use Sonic Stage. But it's a tug of war because I really like the physicality of things like this and the ritual of putting music on it, and also, like we were saying earlier, just using the things, putting it in sideways and putting it in till it clicks and closing the door, and it's just so delicate in there, and I don't know, they're just cool things. And I don't know how many people are familiar with the movie Strange Days. It was kind of a movie ahead of its time. It's from '95. It was a sci-fi thriller about the last days of 1999.
Right.
And there's this drug that's like basically you record an experience and you can sell it to people. And yeah, that's all I will say about that. But yeah, so they used a very mini disc looking thing as the drug delivery system, as the pill in this movie. But also, the battery life is really good. They took one AA, and they will run a long time on one AA, the mini disc player.
For sure.
Well, I totally got MP3s legally off the internet.
Totally legally.
Absolutely legally. Because I just I don't know, I like music so much that I'll just take it however I can get it, as long as I've got something to play it on.
I mean, I think the iPod was, it was one of these big, it was an influential personal media player, right? Like it was bigger, fancier, better looking than a lot of the rest. It had that funny jog dial on it. That small window in time when it was cool enough to be cooler than anything else out there was actually really small if you think about it. Their competitive advantage on the first iPod was they had cornered the market on this super tiny Toshiba hard drive. And these things are awesome. You should, if you haven't seen one of these, it's a little bit bigger than a postage stamp. It's like a small LiPo battery. And the thing is actually a spinning platter hard drive of the super old school. But that was technologically advanced for a very short period of time before all the flash-based storage took over and just completely beat that down. And then they moved over to that, right? And smaller and more minimal screens. And I guess the last iPod standing, the iPod Touch, is kind of bears this out. The cell phone can play your music for you and just completely killed the iPod, because if you gotta lug a phone around anyway, and you can put all your music on it, then why bother with the iPod anymore? And the iPod Touch is essentially an iPhone with the phone part stripped out. They didn't even bother making a different product for it for the last 5 years of its 20-year life. They've just been everybody wants a cell phone. Instead, we'll just take the phone part out of the cell phone and we'll call it an iPod. I mean, it's kind of funny that it hit this short run, but kind of nonetheless culturally significant technological wave that it managed to surf for a while.
Yeah, there's no doubt about they were slick looking.
That about wraps it up for this week's Hackaday podcast. Thanks for listening. If you have any comments, you can write to us, editor@hackaday.com. If you've got any tips at hackaday.com. Links are in the show notes, hackaday.com/podcast. And until next week,
keep on hacking.
Dingleberry. So it was good for me to do that. I'm very proud of me.
We're all very proud of you.
Man, I picked some super nerdy things this time.
Vase mode on, vase mode engaged.
I cracked up while reading it.
Oh, there's one for 75.
Podcast. No browsing eBay.